Welcome students. During this class, we will study about the personal flotation devices, life jackets, and we will go up to the floating and changing by changing of mass. And the sequence of our today class will be the principle of floating and sinking, comparing densities, iceberg, straight ahead, beyond force, and beyond force versus weight versus beyond force. And then we will go up to the topic that is floating by changing mass and floating by changing volume. And then we will see what's the buoyancy and what's the relation of this buoyancy with the densities. So let's start with the personal flotation devices. So personal floating devices, life jackets are filled with substances of very low density. Why? Because it helps to float at the surface. It helps to reduce the weight of the object and to increase the buoyant force. So this this way a life jacket lowers a person's average density, allowing the person to float. So principle of floating, an object displaces a liquid having weight equal to the weight of the object. An object sinks if the weight is greater than the weight of the upthrust. So these are some of the important points to remember when the object will sink. When the object will sink. So this is the reason an object sinks if weight is greater than the upthrust of the liquid on it. An object floats if its weight is equal or less than the weight of the upthrust. So it will float. These are the principle of flotation. When an object floats in the fluid, upthrust acting on it is equal to the weight of the object. In case of floating object, the object may be partially immersed, like ships and boats. The upthrust is always equal to the weight of the fluid displaces by the object. So these are the main points to remember, but keep in your mind, you have to understand when the object will float and when it will sink. When the upthrust is equal to the weight, then it will float. Upthrust equal or more, then again it will be floating. But if the object has more weight than the upthrust, then it will sink. So floating and sinking, how is it possible that the huge ship made of steel can float easily in water, yet in a few hours the same ship can become a sunken wreck like the Titanic? Why? Because why it happens? Because at the same time when you fill up water inside a ship that was full before the time when it was floating, it will result in increase in weight of the object and it will be more than the upthrust of the water, so it will sink like Titanic. So it can possibly be huge ships made of steel can float easily in water. Why? Because we have increased the volume of the water displaced by increasing the size of the shape of the ship. Why does most of an iceberg lies hidden beneath the surface of the water? The answer to this question, you need to find out what makes an object floats and which makes an object sink. So this is the complete detail to get the answers of these questions, when the object will be floating and when object will sink. So here it is comparing the density. One reason object float or sink is their density. An object that is more denser than the fluid in which it is immersed sinks, then the object will sink. This is the relation of density. And why you are using life jackets? To decrease the average density of your body compared to the water. So that's why it becomes easier for you to float at the surface of the water. Why a wood floats at the surface of the water? Because the density of the wood is less than the water, so it floats. Because the upthrust of the water increases, an object that is less dense than the liquid is in which it is immersed floats on the surface like wood. And if the density of an object is equal to the density of the fluid in which it is immersed, the object neither rises nor sinks in the fluid. It floats at a constant level. So this is not it raises up nor it sinks. So it floats at a constant level. So floating and sinking. Now you now while lead sinks, It is several times denser than the water. Why iron or the metal sinks? Because it's several times denser than the water. So that's why these objects, metallic objects, stone and other blocks sinks. Quark, which is less denser than the water, it will float. So this is the reason. Quark have the less density. Is an ice cube more or less denser than the water? This is the question for you to understand, and you will be able to explain. You have to see the ice cubes float at the surface of the water or not. Put some of the ice cubes, take it from your refrigerator, put it in the glass and see if it floats. Then you will come to know that the density of the ice cube is less than the density of the water. So that's why it floats. If in case, if I say if in case it sinks, then you have to conclude that the water ice cubes are denser than the water. But it does not happen. Iceberg straight ahead. An ice cube floats in the water because the density of the ice is less than the density of the water, but it's just a little less. So most of the floating ice cube is below the surface. Since an iceberg is really a very large ice cube, the part of that you see above water is only a small fraction of the entire iceberg. So that's why the weight of the iceberg collectively by increasing size will increase, which will result in moving down from the surface. This is one reason why icebergs are so dangerous to the ships. So they are not visible from the upper side due to heavy weight, increase in weight. They are always present down the surface of the water and it's not visible. So that's why they are dangerous. Why? Because with the increase of the size, their weight will increase. And as a whole, the weight of the water or the volume of the water displaced under the iceberg decreases, which results in iceberg to move down. So here it is. If you look at this is the iceberg, and a large volume of the iceberg is there down the water because its weight has increased. With the increase of the weight, with the increase of the size, its most of the portion is down to the surface of the water. What's the buoyant force? If you have ever picked up an object underwater, you know that it seems lighter in water than air. Water exerts a force called buoyant force that acts on the submerged object and it becomes easier for you with the help of the water molecule to lift the object in the water. Buoyant force acts in the upward direction against the force of gravity. It makes an object feel lighter. So this is the one of side of the buoyant force because it always acts against the force of the gravity. It tries to move the object in upward direction. So that's why whenever an object is immersed or placed inside water, it becomes easier for you to lift that object. But soon you move outside, it will be difficult as compared to the water. So here it is weight versus buoyant force. Weight of the object and buoyant force. These two are equal, then it will be floating. But if the weight is more than the buoyant force, it will sink. But if the buoyant force is more, then it will come up to surface. And if the buoyant force is equal to the weight, it will be suspended, moving at the same place inside the balance. There is always downward force on a submerged object. That force is the weight of the object. If the weight of the object is greater than the buoyant force, then the object will sink. This one. Here it is, it will sink. But if the weight of the object is less than the buoyant force, then the object will begin to float. This one. What can you infer about the weight and buoyant force from the above last picture? That is, when the weight of the object is equal to the buoyant force. This is this one. Changing the density of an object can make it float or sink in a given fluid. So this is the main floating by changing mass, changing the density because mass is linked with the density. Changing in mass means changing in density. So changing in density basically results in floating of the object or sinking of object. Even though you can't change the density of an individual substance, you can change the overall density of the things that are made of several materials. Different types of the materials can be used to change the density of the object. Like if you wear a life jacket, basically as a whole, if you see the distribution of density in your body, that type of the object is also included, which is attached with your body. It means you are basically trying to decrease the density of your body along with jacket, with the help of jacket to float at the surface. Submarines can change their overall mass and therefore their density to allow them to float and sink. Submarine have automatic tanks, water tanks inside their body. These tanks are filled and emptied. With the help of filling with a powerful system, so powerful machines are used to fill up the tanks and to empty to get it empty. So when it these are filled, the water the density will increase. With the increase of the density the submarine will move towards the seabed down to the surface. But when the water is moved out at the same time, then the weight of the submarine will decrease with the motion of the water outside. Uh, Upthrust will increase, which will result in motion of the upthrust submarine upward direction. So these are the basic principles used in case of construction of submarine. They do this by filling or releasing water from their flotation tanks. This is the technique through which they can increase or decrease the weight of submarine by releasing and by filling the water. By releasing, submarines become light. By filling, submarine becomes heavy by filling. So if the weight is equal, then it will float in between. But if the upthrust is increased, then it will come out. But if the weight is more, then it will go down to the bottom. When the water is pumped out of the flotation tanks, the overall mass of the submarine decreases. When the volume of the when the volume remains the same, its density decreases when its mass decreases. So the submarine will float to the surface. What do you think a submarine does in order to sink, to dive? The submarine takes in water. In this way, increases mass. With the increase of the mass, its density increases, which results in sinking. So these are the three different tools that the techniques used, technologies are used, techniques used in case of submarine. To move up to the surface, you have to reduce its mass. To move to the bottom, you have to increase its mass. To keep inside the water, you have to make the balance between the two. To weight is equal to upthrust. So most ships are also designed to alter their overall density. Ships are also made to alter their overall density. The hull bottom part of a ship contains a large volume of air. This air reduces the ship overall mass and therefore the density, and it helps to float. This air is basically uh, used to increase and decrease the density of the ship. If it is decreased, then it will float. If it is increased, then it will sink. Floating by changing volume. Another way of changing density is to change volume. If the mass is kept the same, increase the volume of the substances will decrease the density. Increasing the surface area of the substance will also increase its buoyant force. Surface area and surface area is increased like we have seen during the last class. Block in a ship of the same weight. The surface area in case of block was very less, but surface area in case when you have converted this block into ship size, then it will increase. By the increase of the volume, you have decreased the density. This is because the greater is the volume of the water displays, the greater will the buoyant force, Archimedes principle. The shape of ship causes it to displace a great water of volume than a solid piece of a steel of the same size. If you look at the ship is having this type of the shape, this one. But in case of the block, the size of the block is this one. Both have the same mass, but here the volume is less, here the volume is more. Here is the volume of the large size. So it happens in case of the ship, you have increased the volume to increase the upthrust, but here the same mass but less volume. Here the upthrust will be less, it will sink, but in this case it will float. So this is the reason why the volume of any substance when it is moved plays an important role in floating the object. Greater the volume of the water displaced, greater will be the buoyant force, Archimedes principle. The shape of the ship causes it to displace a greater volume of water than a solid piece of the steel of the same mass I have discussed in this example. So it has greater surface area. The more water it displaces, the easier it is to float a ship. A ship always floats as long as the buoyant force is greater than its weight. If the buoyant force is greater than the fear force, it will keep on floating at the surface. So here are the ships. If you look at the buoyant force, this is the shape of the ship down. By this, you have increased the volume of the ship which is in contact with the water. It has increased basically the volume of displaced water under the ship. So it has automatically increased the buoyant force, which will help in the ship to float. The shape of the ship causes it to displace a greater volume of the water than a solid piece of a steel of the same mass. If you take same mass of the solid, this one, it will displace very much small volume, and as a result the weight will increase and it will sink, but the ship will float because its volume is more. Greater the volume of the water displaced, the greater will be the buoyant force. A ship stays float as long as the buoyant force is greater than its weight. When it will be floating, when the buoyant force is greater than the weight. So here it is, buoyancy and density. Buoyant force, here the buoyant force is acting, here the weight is there. Again, if you see, this is the weight and this is the buoyant force. If you see, this is the weight and this one is the buoyant force. What you have done, write it down in your notebook. This is the way. Another way to changing density is to change the volume. With the change of the volume, basically you will change the density. So density of submarines, this is another example by filling and by moving the water outside the water tanks, floating tanks. So density of submarine, changing the density of an object can make it float or sink in a given fluid. For example, submarines change their density by pumping water out of its flotation tank. The mass of the submarine decreases, but the volume remains the same. So this is the technique used by taking in and by giving out the water. By this way, the density of the submarine is increased and decreased. Depending on required situation, the same action is taken and it is applied on the submarine. So here again, this is the density concept of the density. When it will be same, what will happen, and when it will be more, what will happen, and when it is equal. When buoyant force is more, then it will be floating over. When weight is more, it will sink. Then the buoyant force is less. Here, both are equal. It will be suspended. It will move. So floating and sinking. If the object, if the weight of the object is less than the buoyant force, the object will float like this one. Here is the reason where the weight is less than the buoyant force. If the weight of the object is exactly equal to the buoyant force, the two forces are balanced, like this one. It is suspended inside water, can, sinking and floating. Object will only sink deep enough to displace a volume of the fluid with a weight equal to its weight on, and a weight equal to its on. At that point, it will stop sinking deeper and will float. So this is the reason where the weight of any object becomes equal to the water displaced, then it will not sink more. It will be suspended. Floating and sinking. There is always a downforce in submerged object, the object's weight. If the weight of the object is greater than the buoyant force, the net force on submerged object will be the downward and the object will sink. It happens when the weight of the object increases. So here it is another example, submerged object. Submerged object takes the place of a volume of fluid equal to its weight of its own volume. So object will that floats on the top of the water only take the place of the volume of the fluid equal to the volume of the amount of the object in liquid in the fluid. With this, our class ends. I thank you very much for your patience. Hope you people have understood today's topic.